So let's continue with triangle similarity, and let's review what we know about scale factor from when we studied our transformations unit. Remember, it's represented by a lowercase letter k. It's always the comparison of two corresponding parts where you put the newer value in the numerator and the one from the first figure in the denominator. So it's the same as image compared to pre-image of two corresponding parts. Just remember that if it's reduction, k has to be between 0 and 1, and that's the absolute value of k because we always deal with positive values. And for an enlargement, the absolute value of k is greater than 1. And similarity ratios can be written a over b, a colon b, or a, put in the word 2, T-O-B, but we read them all a to b, a to b, a to b. Okay, so let's look at a guided example. Given two triangles, determine whether the triangles are similar. P represents pre-image and I represents image. So let's come here to our first example. Remember, they gave you what's called a composite figure because it looks like you have a nested smaller triangle inside a larger one. So feel free to redraw them, transferring the values to them. Looks like we could be trying to get side angle side here because we have the congruent angle in the green triangle, the large one, congruent to this angle here. Why are they congruent? Because they're both the exact same angle. It's that one angle used for both triangles. Then the long side of green, 11 plus 11 would be 22. You see the tick marks, so you know this side's just 11. And here you have 8 plus 5 to get the whole side here. And, excuse me, that's a 5 and a 5. It's hard for me to read that, but the tick marks say 5 plus 5 would be 10, and then on the orange one you just have the 5. So you go to set up the scale factor, I over P. Since the image is the smaller one, that value has to be in the numerator, so you can do the 5, or you could do the 11, but the 5 has to be paired with the 10, because those are both on the same side, they are the corresponding sides. And the 11 have to be paired with the 22. Both have the exact same ratio, 1 to 2. So you have side, angle, side in green to side, angle, side in orange. Therefore, they are congruent. Now you say, is it an enlargement or reduction? Since you're going from the large pre-image in green to the small orange triangle, which is the image you end up with at the end, it is a reduction. You got smaller. Side, angle, side. The next example actually is not going to work, right? Let's see why. So you have this triangle, and if I go with my French fries, where I take the smallest side and call it 10 units, small, 18's medium, is that 20 or 30? Looks like it's a 20 is large. And I do the same thing over here for what's small, medium, large. It's a 6, a 9, and they left off a value. That's what happens sometimes. So since we don't have a third side, we cannot guess, we cannot assume. This problem cannot be done. You need more information. Okay. These pictures you will see often in similarity units. What I want you to think is whichever two sides are part of a line, they are going to be the two sides that correspond. So I'm going to be comparing the length of the two pink sides as corresponding and the lengths of the 12 and the 18 as corresponding sides. And of course we can tell in these triangles the shortest sides are completely opposite each other. So what we're looking for here is markings on the angles, and I'm trying to see if they gave me that information or if there's something I can see. I know I've got vertical angles right here, and the trick is these orange lines here are parallel to each other because we see the arrowheads. That means when this transversal cut across the orange parallel lines, let me circle the parallel markings so you're sure to see them. That makes this pink arc and this pink arc alternate interior angles. So alternate interior angles are always congruent. We learned that in a unit. Then we have vertical angles always congruent. So I have two angles of this triangle outlined in yellow, congruent to two angles to this triangle that's smaller on the right. That's all it takes to be similar. Angle, angle, similarity. So to put my corresponding sides in the right place, since I call this one T-O-N, I started on this side, I'm going to have to go T, V, W. Now I go back and do my scale factor. My image is marked with an I, so I can take any one of those values. Let's say I want to take, well, they're going to compare them all. So the 12 corresponds to the 18, the 14 corresponds to the 21, and those both reduce to 2/3. Okay? Since scale factor is always I over P, we're ending up small, we're starting big, it is a reduction, so we do need a number that's less than 1, greater than 0, and it was a reduction.